Most kinds of cognitive ability models are hierarchical in nature. We refer to some abilities as broad, and some of them as narrow. We use these terms so often that it's easy to forget that they're metaphors. We don't actually think that abilities have width, and we can measure it with a ruler. So what do these metaphors mean? Well, the meaning of the metaphor depends on which kind of hierarchical model we have in mind. I want to talk about two kinds of hierarchies. The first, and by far the more common, conceptualizes breadth in terms of different levels of generality. To illustrate, consider a very simple and very abbreviated model in the domain of gross motor activity. Walking is a very general activity. It's an essential ingredient in many, many activities. If you have difficulty walking, there are many activities that are going to be very difficult for you. In contrast, shot putting is a very narrow ability. Why? Because if you're otherwise healthy, but you're not a very good shot putter, there aren't many things that are barred from you. Being a poor shot putter, if you're otherwise healthy, does not limit your life in very many ways, in the same way that if you had great difficulty walking, would limit your life in many ways. Now notice that walking and shot putting are both abilities in the same sense. They are abilities. Just one is more general, meaning it's an essential ingredient in a wide array of tasks and goals. Shot putting, much more narrow. The CHC model of cognitive ability is a good example of this kind of model. It's a hierarchy, and each of the abilities in the model are abilities in the same sense, but some are more general than others. At the apex of the model is an ability that you would call G. If a person's level of G is very low, it shows up in a wide array of tasks. In contrast, consider fluid intelligence. It's a broad ability, but not as broad as G. Fluid reasoning consists of two parts. One is the influence of G, and the other is some unique component that is not part of G. If you have low levels of this, it shows up everywhere. If you have low levels of this, it shows up here and here alone. Now this is a fairly broad ability, and it consists of a wide array of narrow abilities. Here are three: sequential reasoning, quantitative reasoning, and induction. Now each of these broad abilities have their own narrow abilities, but they're not shown here. So these three abilities are what we call narrow abilities, and they are abilities just like fluid reasoning is, and just like G is. Each of these abilities have two parts. One, a unique part, and I've only shown one of them, but each of these would have its own orange oval, and the part that's related to GF, which can be further subdivided into the unique component of GF and the component that's related to G. So there's a unique component to each of these abilities, and these are abilities in the same sense as these others, except that they're more narrow, meaning that if you're bad at this, it'll show up on certain kinds of activities and tests. Now, each activity and test has its own unique component and also measurement error. If you're bad at this, but okay at this, you'll be bad at this, but not this. If you're bad at this, but not the unique component for this, it'll show up in all of these tests, but no tests of quantitative reasoning. If you're bad at this, it'll show up in all of the narrow abilities related to GF, but it will not show up in the narrow abilities related to GC. If you're bad at this, it shows up everywhere. Here's another hierarchical model. It states that there's an ability called arithmetic, and there are narrow abilities, one related to each of the major four operations. Now you may have some other model of arithmetic in mind. That's fine. I'm not saying this is the right one. I'm just saying here is a hierarchical model of arithmetic. Now what this model says is that there's some ability called arithmetic, and then there's another ability, a narrower ability, that is just related to addition. And there's another one called subtraction, and there's another one called multiplication, and there's another one called division. And if you're bad at this, it shows up everywhere. If you're bad at this, it just shows up here. Now, you're probably thinking, why, that seems really unrealistic. This just does not seem to fit arithmetic. Well, why? Because what is this ability called arithmetic? What specific skill is it? It's not addition, because that's addition. Arithmetic isn't subtraction, because, well, that's subtraction. What is this thing? Well, it's not really a thing at all. Maybe we need a different kind of hierarchical model to account for something like arithmetic. Our second kind of hierarchy refers to broad abilities and narrow abilities, not in terms of different levels of generality, but instead in terms of different levels of abstraction. What do I mean by this? Let's take addition again as our domain. So we can have a test of addition, a test of subtraction, a test of multiplication, and a test of division. And we can imagine that there are a whole bunch of very narrow subskills, things like rounding and counting by fives, and a whole bunch of them. I've just shown a few here, but you can imagine that there would be many little sub-abilities, some having to do with fractions, some having to do with decimals, just little micro skills. And some of them map onto one and only one kind of operation. And for this reason, it makes sense to think of these abilities as being related. That there's something called addition, there's something called subtraction, there's something called multiplication, there's something called division. But really what they are is a set of micro skills that are related in a functional way, mostly because they're taught and tested together that they are related. But they are abstractions. What's really happening is that they're a bunch of little micro skills and they all work together in some way. The working together part allows us to think of these things as functional unities. Now, it's obvious in the realm of arithmetic, it's not this simple. What's probably going on is these micro skills, some of them apply across operations. There are certain skills in addition that apply in subtraction, multiplication, and division. Now you can see this one here has an arrow to each of the 4 operations. Why is this not just our general arithmetic skill? Well, because it's a micro skill, not a general skill. It just happens to be a micro skill that is used in all of these things. It is not arithmetic itself in totality. It is a certain micro skill that is used in a wide variety of tasks. Things like being able to count. Things like being able to recognize numbers. Now notice how entangled this model is that it's actually pretty difficult to measure things really cleanly. And for this reason, because they're entangled, it's legitimate to think of these things as belonging to a wider domain, a domain of arithmetic. Now, there is no ability called arithmetic, but we call these different microskills part of this domain of arithmetic because they are taught together, they are tested together. It's difficult to think of them as separate. Let's compare this model with the hierarchical model. Now, the hierarchical model doesn't have just one little microskill going into each of these things like I depicted earlier, but we can imagine many little microskills feeding into this broad thing called arithmetic. In this case, we've got an abstraction here. There is no one ability called arithmetic. It's a collection of a whole bunch of general abilities that have influences all over here. So if you're not very good at this, it's going to manifest itself in all of these operations. So the difference between this and this is not that large, and they're not mutually exclusive. There's no one that this is the right one and that's the wrong one. It's different ways of looking at the same thing. But for me, it's helpful to think of arithmetic not as some general ability. There's this ability called arithmetic. But really what's happening is there are a bunch of little micro skills that are connected in some way, and for me it's easier to visualize like so. How can we take this kind of model and apply it to cognitive ability models in general? So here we have a collection of cognitive abilities related to crystallized intelligence and fluid reasoning. Fluid reasoning in blue here we have sequential reasoning, quantitative reasoning, and induction. We have 2 narrow abilities in crystallized intelligence, general knowledge, and language development. Now, in truth, all of these abilities, they're not that narrow. They probably consist of a bunch of little micro skills. But the way that we test them, the way that we learn them, is that they have some sort of functional unity. Suppose we want to measure this in a study. Well, we might think, well, let's get a few tests of sequential reasoning, a few tests of quantitative reasoning, a few tests of induction, a few tests of general knowledge, and a few tests of language development. If we do confirmatory factor analysis, we might suppose that we'll get loadings like this. Now, we can model correlations between these things, but I'm going to leave those out for now. The fit to this model might be actually pretty good. However, that doesn't mean it's right. Confirmatory factor analysis depends on a covariance matrix. Covariance matrices, as pointed out a long time ago by Godfrey Thompson, are very, very tricky, and there are many, many, many ways of producing the same covariance matrix with really different models. And what he proposed is a variant of what I've been talking about in this second kind of hierarchical model, is that really what's happening is that there are all sorts of little micro skills that load in all sorts of different ways on all sorts of different tests. So here's an example of what might be going on. That in most tests of inductive reasoning, we can imagine that there are quantitative aspects, there are sequential reasoning or deductive reasoning aspects, and they have an influence. Maybe not as much of an influence as induction does, but they do have an influence. And because these 3 abilities are entangled in this way, and we just don't have enough resolution in our tests to distinguish clearly between them, we think that we're getting this kind of model when really what's happening is this. Now, this entanglement that we see here is justification for saying that these 3 abilities are related in some way, that there's this abstract category called fluid reasoning. Now, notice here that there is no ability called fluid reasoning. It's a category of abilities. And this category is legitimate because of this entanglement here, that they're related in some way and they're difficult to separate and they are part of the same domain. But there is no thing called fluid reasoning. What's really happening is a bunch of little micro skills that are difficult to disentangle. Likewise, crystallized intelligence works the same way. Language development and general knowledge aren't this separate, that they are entangled in all sorts of different ways. And because of this entanglement, it's legitimate to talk about these narrow abilities as part of a broader category called crystallized intelligence. It doesn't just stop there. There are cross-loadings across these different categories that language does figure into measures of fluid reasoning, and fluid reasoning definitely figures into measures of crystallized intelligence. Now, because of this entanglement here, it's legitimate to think of broader categories, and we could call this broader category whatever we like. I'm going to call it G because that's what we've been calling it all along. Now, it doesn't just stop here. There are other abilities that I've not shown, visual spatial skills, auditory processing skills. What I'm talking about is that there's no ability called G. G emerges because these things are difficult to disentangle. As stated earlier, each of these narrow abilities are probably abstractions in and of themselves, but they are less abstract than GF, GC, and then obviously less abstract than G. Now, when I say abstraction, I do not mean mere abstraction. Let's take another example to illustrate. So here we have a much less entangled domain here, but the domain of sensory perception. Hue discrimination, depth perception, edge detection are just a few of the little micro skills that we consider part of vision. No one ever says there is no such thing as vision. Vision doesn't exist. What's really happening is hue discrimination and depth perception and edge detection and a whole host of other vision-related micro skills. It's legitimate to talk about the category of vision. Why? Because they work together. They work in tandem. Likewise with audition or hearing, there are a bunch of different micro skills that are all operating independently, and any one of them can be taken out with neurological insult. But they do work together, and for this reason, it's legitimate to talk about them as belonging to the same general abstract category of audition. And likewise, vision and audition do not work separately and independently. We do use them in tandem. They work together, and it makes sense for us to talk about a broader category of sensory perception, sensory discrimination, the sensations. We use our sensory abilities to make sense of the world, and we don't use them in isolation, and sometimes they're difficult to disentangle. So if I say that sensation is a mere abstraction, it doesn't matter, it doesn't exist, that's not true. It is important. It's important to talk about the ways that these things work together, and it's important to talk about sensory abilities. It's a legitimate category, but it is not the same thing as saying there's this thing called sensation, and it's an ability. It's not an ability. It's an abstract category of abilities in this model. So when it comes to cognitive abilities in general, which is the right way to think about it? This way or that way? I'm not really sure. I do think that it's important to keep these things in mind so we don't get locked into one metaphor versus another. It's possible that some parts of cognitive ability really do fit this kind of model, and other parts that really fit this kind of model. Or it's possible that there are two ways of thinking really about the same thing. Keeping both in mind allows for greater flexibility and less chance of error.